Hey there, Mr. Weaver here, and this is 8th grade, Module 6, Lesson 4, Solve Systems of Equations by Elimination. After this lesson, you need to be able to use elimination to solve a system of linear equations. Let's learn. Solve systems by elimination, addition. Elimination is our third method that we can use to solve systems of equations. So far we've done graphing in Lesson 1 and substitution in Lesson 3. Here we're going to learn how to use what's called elimination. And elimination is going to either be done by adding, subtracting, or multiplication first, then followed by adding or subtracting. So the use of addition or subtraction to eliminate one variable in a system of equations is called elimination, since one of the variables is eliminated. Elimination is an algebraic method where we can use it to solve our systems of equations. So let's look at how to solve using the example they gave. So first, we're going to look for opposite coefficients or same coefficients for the variables in both equations. So here we can see we have in front of y, we have opposite coefficients. Having it set up like this, if we see that in our equations, that's going to be a hint for us to probably try to use elimination. Another way that we're going to look for to try to figure out if we're going to use elimination is if they're all set up in standard form, which means it's something x plus something y equals a number. If they're both written like that, use elimination. Or if one of them's already written that way and you can easily get the other into that form, then elimination is probably your best bet. So here, our coefficients are opposite, which tells us that we should add them together, because if we do that, positive 3 minus 3 gives us 0. So by adding the two equations together, we eliminated the variable of y. And since we added, we just add everything else together. So 1x plus 4x equals 5x, and negative 3 plus 18 is 15. I end up with 5x equals 15, so divide both sides by 5, x is equal to 3. By adding the equations together, I effectively eliminated the y, so I was able to solve for x. Sometimes you can solve for y, sometimes for x. Whichever works out easiest, we're going to combine the two equations together. Once we've eliminated a variable and solved for what's left, then our steps are the same as substitution, where we're going to take what we got and plug it into either equation to solve for the other variable. So we just saw that x was equal to 3, so instead of x, let's plug in 3. 3 plus 3y equals negative 3. If I subtract 3 from both sides, I get negative 6. Divided by 3 gives me negative 2. So just like with substitution, solve for one, then plug it in to solve for the other. Finally, we'll write it as an ordered pair. My x value has to go first, then my y value. So make sure you're paying attention to which one you are solving for first and which one you solve for second. And that way you put them in the correct order. So x was 3, y was negative 2. And as we did with substitution, we should double check our coordinate into the other equation just to make sure that it works, but we'll look at that in our examples. Example 1. Solve systems by elimination, addition. Solve the systems of equations by elimination. We have 2x plus 5y equals 3, and we have 4x minus 5y equals 21. So first, if I'm using elimination, I need to figure out what is going to be the easiest way to eliminate one of the variables, either adding them together or subtracting them. So here we have opposite coefficients. I have plus 5 and minus 5 with y. So that's good. That's what we need for elimination. They're opposites, so I can add. Adding will get me 0. So we're going to add all of these together. I like to put a plus by each thing so I remember that I'm adding, especially if I see a negative. I don't want to accidentally subtract and mess up my totals. So 2 plus 4 gives me 6x. Positive 5 plus negative 5 gives me 0. 3 plus 21 gives me 24. I eliminated my y's. They're at 0. 6x equals 24 is what's left. So if 6x equals 24, then divide by 6, x is equal to 4. Now that I know that x equals 4, let's substitute that value into either of the original equations. So here we have 2x plus 5y equals 3. I now know that x equals 4. So 2 times 4 is 8. 8 plus 5y is equal to 3. 8 from both sides. 3 minus 8 is negative 5. 5y equals 5, so divide by 5, y equals -1. So the solution to the system is going to be 4 for x, -1 for y. We should check by plugging it into the other equation too. We said x was 4, y was -1, so 4 for x. So 4 times 4, that's going to give me 16, minus 5 times -1. Minus 5 and -1 would actually make this +5 or +5. Is that equal to 21? 16 plus 5 is 21, so that does work out. Since it was true in both our top equation and our bottom equation, same for x and y, this is our solution. We just had to double check. Check your understanding. Solve the system of equations using elimination. Pause the video now and complete the check. Check your answer. You should have found x was -2 and y was 0, so your ordered pair is -2, 0. If we're using elimination here, this is a coefficient of -1, this one's a +1. They're opposite coefficients, so we should add all of these together. 4 plus 7 is 11 with our x's. -1 plus +1 gives me 0. -8 plus -14 is -22. If 11x is -22, that means x must be -2, which is what we got. Let's plug in 4 times -2 minus y equals -8. This is -8. Take away something is equal to -8. I can see right away, even by taking away, I end with what I start, so this must be 0. But if we add 8, it's gone there. -8 plus 8 is 0. So -y is 0. So y is 0. If I plug in the same things for the next one, I get -14 plus 0 equals -14. That works there too. So -2 and 0 is my combination of x and y that works in both equations at the same time. And if I were to graph this, I could also check that this is the point that those two equations intersect. Let's learn. Solve systems by elimination, subtraction. When the coefficients of a variable are the same, then subtracting the equations will eliminate the variable. So we just saw when they were the opposite, we would add. When they're the same, we subtract, because subtracting is really just adding the opposite. So if we're subtracting, we really have a couple of things we can do. We can either subtract or we can add the opposite. If we're given these two equations, we have 4x plus 5y equals 18. And -2x plus 5y equals 6, we can use elimination since they're both set up in the standard form of ax plus by equals c. I see plus 5y and plus 5y. They are the same, so I want to subtract or add the opposite. Here we can see, doing both things, they're showing subtracting this whole thing is the same as if you add the opposite. So instead of it being negative, it's now positive. Instead of it being positive, it's now negative. They just changed the signs of everything. Now there's opposite coefficients, so we can add. But I'll show you in a second. Subtracting will give us the same thing. So when I do that, I get 6x adding the x's, 0 adding the y's, and 12 adding the constants. Had I just subtracted, so I did 4 minus -2, 5 minus 5, 18 minus 6, we will get the same thing. We just have to be really careful with the double negatives. So 4 minus -2 ends up being 6. 5 minus 5 is 0. 18 minus 6 is 12. So I do end up with the same values by adding the opposite as I do by subtracting. It really depends how many negatives you have of which method you want to use. From there, our steps are the same. So we're going to solve for one variable. We just had 6x equals 12. So x equals 2. Once I know what that value is, I'm going to substitute it back in. So plug in 2 for x and figure out what y is. So I would add 4 to both sides. I get 5y equals 10. So y must be equal to 2. So this solution would be 2, 2. Both x and y were 2. Example 2. Solve systems by elimination. Solve the system of equation by elimination. We have 8x plus 2y equals 12. 8x plus 4y equals 16. So again, when I'm using elimination, I'm looking for the ones that have coefficients that either are the same or opposites. So I have 8 and 8. Since they're the same, we're going to use subtraction to make it 0. Here they're showing adding the opposite. So the opposite of the bottom one is negative 8x minus 4y minus 16. So when we write it, we'll do opposites of all of them so we can add. I'm going to write the symbol in between all of them again, just so I remember what I'm doing. 8 plus negative 8 is 0. 2 plus negative 4 is negative 2. 12 plus negative 16 is negative 4. Solve for the variable that remains. Negative 2y equals negative 4. So this must be 2. Y was equal to 2. Now I'm going to substitute 2 in for y. 2 times 2 is 4. So 8x plus 4 is equal to 12. If I take away that 4, I get 8. 8x equals 8. X must be equal to 1. So the solution here would be 1, 2. If you were thinking it was 2, 1, again, we need to remember x goes first, then y in our coordinates. So even though we solved for y first, y was 2, x is 1. Please be careful. Check your understanding. Solve this system by elimination. Pause the video now and complete the check. Check your answer. You should have found negative 1 and 4. X was negative 1, y was 4. I'm going to rewrite this. So this bottom one, I'm going to do the opposite so I can add instead of subtract. Negative 6x plus 5y is 26. That stayed the same. Opposite of negative 6 is positive 6. Opposite of positive 2y is negative 2y. Opposite of positive 14 is negative 14. Now I can add all of them. Negative 6 plus 6 is 0. 5 plus negative 2 is 3. 26 plus negative 14 gives me 12. So 3y is 12, meaning y is 4. 3 times 4 is 12. Once I know that y is 4, I can decide which one I want to plug it into. I can use the top one, the bottom one of the original, or I can even use my one that I changed it to. I'm going to do that. So I have 6x minus 2 times 4 equals negative 14. So 6x minus 8 is negative 14. If I add 8, I get 6x equals negative 6. So x equals negative 1. It doesn't matter which one you're plugging it into. You should be able to solve for both x and y. Once you know one, you can figure out the other. We should double check to make sure that both of these work in a different equation. Maybe this top one here, since we haven't used it yet. Just to double check. So if x was negative 1, this comes out to be 6. If y is 4, this comes out to be 20. 6 plus 20 is 26. So we must have done it correctly. Negative 1 for x, 4 for y. Let's learn. Solve systems by elimination, multiplication. Sometimes elimination is the easiest method, easier than substitution or graphing, but there are times when the coefficients won't match up correctly for you to use elimination. Instead of rearranging and trying to get one thing in for substitution, what we can do is multiply one or both of the equations so that the coefficients match up enough for us to add or subtract and eliminate the variable. So if we look here, we can see we have 3x plus 2y equals 12. And then in our original, we have negative 1x, 4y equals 10. The 3 doesn't match with a 3, 2 doesn't match with a 2, or 4 doesn't match with a 4. Nothing matched with the coefficients. But if we multiply the second equation by 3, I can make a new equation. That would be negative 3x plus 12y is equal to 30. So this second equation is the same as this first. We just multiplied by 3. And since we multiplied both sides of the equation by 3, right, here's the left side of the equation I multiplied by 3. Here's the right side of the equation. All I did was multiply both sides of the equation by 3. I'm allowed to do that with the multiplication property of equality. I made a new equation where I can now use elimination. So now they have opposite coefficients, 3 and negative 3, which means we can use addition. So let's add the two together and solve for the variable that's left. I get 0x. Adding those, I get 14y. Adding those, I get 42. 14 times something is 42. Divide by 14. That something must be 3. Now that we know that y is equal to 3, plug it back in and solve it how we've been doing. So 2 times 3 is 6. Subtract 6 from both sides. We get 3x equals 6. And then x must be equal to 2. Finally, as we've been doing, we have to write it as an ordered pair. So when we solve this, we solved for y first. Y was 3, x was 2. So make sure we write it in that correct order. Example 3. Multiply one equation to eliminate a variable. Solve the system of equations by elimination. Check the solution. We have 2x plus 5y equals negative 13, and x plus 3y equals negative 5. It's set up for us to use elimination. I have something x plus something y equals a number for both equations, but none of the coefficients match up. We have 2 and 1 and 5 and 3. They don't match up. We can't eliminate as it is. But, as we just saw, we can multiply one of them to set it up so it does match. If I multiply the bottom equation by 2, then I would match up with 2 and 2. Or, even better, if I multiply it by negative 2, then I end up with positive 2 and negative 2. So then I can add. So what can we multiply by? We can multiply by negative 2. If you didn't see the negative 2, you just saw positive 2, then you could have used subtraction and subtracted the opposite. But negative 2 gives us that already. So let's multiply everything in that second equation by negative 2. First one, we end up with negative 2x and minus 6y. Second, we end up with negative 2 times negative 5 is positive 10. Now, since our coefficients are opposites, we can add them. So positive 2x plus negative 2x is 0. Positive 5 plus negative 6 is negative 1. And negative 13 plus 10 is negative 3. I end up with 0x, so that's gone. Negative 1y is equal to negative 3. Divide by negative 1. Y must be equal to 3. Now that I know that y is 3, let's substitute that back in. 3 times 3 is 9. So something plus 9 is negative 5. If I take away 9 from both sides, I find that x is equal to negative 14. So the solution then, I would say x goes first, negative 14, and y was 3. Last, let's check in both of the original equations. We said x was negative 14 and y was 3. So if we check the first one, plugging in negative 14 for x, 3 for y, I end up with negative 28 plus 15. Is that equal to negative 13? I get negative 13 equals negative 13, so yes. If I plug in those two things for x and y in the other equation, I end up with negative 14 plus 9. Is that equal to negative 5? I get negative 5 equals negative 5. So again, that is also true. Since this is true in both equations, that is our solution, negative 14, 3. And if we were to graph these equations or use Desmos to help us out, just to check, we would see that these two equations do intersect at negative 14, 3. Check your understanding. Solve this system by elimination. Pause the video now and complete the check. Check your answer. You should have found that x is equal to 1 and y is negative 1. If I'm looking, nothing matches up. 1 with 7, 2 with negative 3. I can multiply this top one by negative 7 and I'll get opposite coefficients. So if I do that, I get negative 7x. Negative 7 times 2 is negative 14 for the y. Negative 7 times negative 1 is equal to positive 7. The bottom one didn't change. Since I made it with these having opposite coefficients, I can just add them. I get 0. Negative 14 plus negative 3 is negative 17 for the y. That's equal to 7 plus 10, 17. So negative 17 times something equals positive 17. Y must be equal to negative 1. I could get that by dividing by negative 17. Now to figure out my x value, I'm going to just use the original equation. So I have x plus 2 times negative 1 equals negative 1. I don't have to use the one that I changed it into. I can use my original. So x minus 2 is equal to negative 1. Add 2, x is equal to 1. So y was negative 1, x was positive 1. I have to write them in my correct order though, so positive 1, comma, negative 1. Example 4. Multiply both equations to eliminate a variable. Solve the system of equations by elimination. We have 6x plus 2y equals 14 and 4x plus 3y equals 1. Sometimes you're going to see it set up perfectly for elimination. Your x's are aligned, your y's are aligned, your constants are aligned, but your coefficients don't match up, and there's nothing that you can multiply by one of them to get to the other. Yes, I know that I could multiply by like 1.5 and get 3 for both of my y's, but we don't want to do that. We want to stick with integer numbers. If this is the case, just multiply both equations and come up with two new equations that have coefficients that match. If I multiply the top equation by 3, so 3 times 6, I get 18. 3 times 2, I get 6. And then 3 times 14, I get 42. Why did I choose 3 to multiply? Well, by multiplying by 3, I can make a coefficient in front of y that's easy to get to by multiplying something in the second equation. In fact, if I multiply negative 2 times 3, choosing that negative value so they're opposites, I end up with negative 6. That's why I chose 3 and negative 2, so I can eliminate them. 3 times 2 is positive 6, negative 2 times 3 is negative 6. I'm able to eliminate that variable by choosing things that work together to give me matching coefficients. Now, since we have opposite coefficients, let's add to eliminate our variable. If we add all of these, 18 plus negative 8 gives us 10. Positive 6 plus negative 6 gives us 0. 42 plus negative 2 is 40. 10x must be equal to 40, so x is equal to 4. I divided by 10. Once we know that x is 4, let's plug it back in. 6 times 4 is 24, plus 2 times something is 14. If I take away 24, I get negative 10. 2 times something is negative 10, so that something must be negative 5. So the solution to this, x was 4, y was negative 5. I write them as an ordered pair of 4, negative 5. And again, if I were to graph this, this is the coordinate where the two lines would intersect. Check your understanding. Solve this system by elimination. Pause the video now and complete the check. Check your answer. You should have found x was 1 and y is negative 3. To get this, nothing matches in our coefficients, so we need to make some new equations. And I can't multiply anything to go from 6 to 5, or 4 to 3, or 3 to 4, or 5 to 6. So let's multiply both equations. The easiest way to do it is just to multiply by what's out front. So if this is a 5, multiply the top by 5. If this is a 6, multiply the other by 6. Since they're opposite signs already, just keep them opposites by multiplying by both positive numbers. If they were the same, then pick one of them to make negative. 5 times negative 6 is negative 30. 5 times negative 4 is negative 20. 5 times 6 is 30. 6 times 5 is 30. 6 times 3 is positive 18. 6 times negative 4 is negative 24. We have opposite coefficients right here. Add them. So that gives us 0. Adding negative 20 plus 18 gives us negative 2. Add them. 30 plus negative 24 gives us 6. Negative 2y equals positive 6. So divide by negative 2, y must be equal to negative 3. Negative 2 times negative 3 would give us positive 6. Then I got to plug this back in. I could use either of the two that I just came up with, or two of the originals. It doesn't really matter. I'm just going to pick the top one. So negative 6x minus 4, y is now negative 3, equals 6. This is now positive 12. Subtract 12. Negative 6x equals negative 6. So x equals 1. So putting them together, my x value was 1, my y value was negative 3. And I should check these in the other equation, but for sake of time, it is correct. And you can verify it if you want using Desmos and finding that that is where the graphs intersect.